Okay.
Hello, everybody, and welcome. Today, we're going to be creating views using mySQL. And today we have Bukola Olafenwa who will be showing us how to do it. So over to you.
Thank you so much, Margaret. Good evening, everybody. Welcome to this session. I'm so happy to be here. It's fun discussing views, particularly MySQL. So, we had a session last week, Thursday. So today is just like a continuation of what we did. So, um, I always say that there is always more than one way of doing things, and it reflects even in tech. So there is more than one way of, trying to, make coding easier, to make it less stressful. But this particular one that is very, very obvious that we use often is the view. So for those who code in MySQL, yeah, you would know is a very popular concept that the view always makes coding less stressful. But how does that work? How does it happen? All this I'm going to be discussing and demonstrating today in my presentation. So once again, I'm Bukola Olafenwa. I'm an academic mentor at the Letter Trust in London, and trying to transition into tech has led me to studying MySQL programming language, and I'm currently learning Python. But now it's fun to do MySQL, and it's my great pleasure to share knowledge about the concept of views, what's about views, how we can use them, and how it can benefit us. So right now I'm going to share my screen. Okay. Okay, so I'm presenting an introduction creating views with MySQL. Okay, 1 second. Okay. Now in my presentation, I'm going to define a view and discuss the syntax for creating a view. After which, I'm going to outline and demonstrate how we can create views in 3 ways. 3 major ways include creating views based on base tables, creating views based on other views, and creating views to replace existing views. So these 3 ways, we're going to discuss them and I'm going to demonstrate them live. After which, I'm going to give a brief summary of everything I'm going to be presenting this evening. But before I start, let's just go to the very first thing, which is defining a view. And that is, what is a view? It's a very big question with a capital, with a bold question mark. It is popularly known as a virtual table. We say it's a table and then it's virtual, kind of give you kind of mixed feelings. Yeah, that is what it is. Because as a view, it is a virtual table that does not have original data of its own. It is based on the results of queries, MySQL queries or SQL queries, yeah, that have been written to query the database. And in this select statement, we know that when we want to query a database and write a select statement, either in MySQL, PostgreSQL, just name it, we are bound to reference data sets from different base tables. So now when you want to query a database, for example, in the database I'll be using this evening to demonstrate, it is the database of a grocery store. And then here we have maybe the product table. And then we need information from the product table, maybe the product ID, and maybe something related to the sales of such a product. Definitely we have to go to the sales table. So maybe we take the sales amount from the sales table, and then we also reference the product ID from the product table. All these are base tables, and they will be included in the select statements. So what a view does is that when a select statement is written and you use it successfully, And maybe you may need to rewrite this same select statement, this same query often. Like maybe you need to write like 3, 4 times in a week. It is not wise that you just write it once and discard it. No, you need to keep it. And one big way, one beautiful way we can keep our codes for reuse is keeping it in a view, creating a view to contain it and store it as an object in a database. So in this sense, a view can be summarily defined as a virtual table that feeds on the data of base tables, and it is even possible for it to feed on data from views that already exist in the database. So today we're going to see how it works. And because, it serves as a container of queries we have written already. When you write a query and you want to keep writing you keep writing often, you don't have to discard it. The view, gives you the opportunity to keep it. It keeps the select statements for us. As a result, it promotes code reusability. And by doing so, the time and the stress you have to go through, having to rewrite often and often is eliminated. You just, you find it easier to code, you find it easier to query the database and to retrieve information from the database. All this I'm going to be experimenting this evening. So we have discussed the view, and then we want to talk about the syntax for creating a view. It's so easy. Now we have commands in MySQL, and one such commands to create stuff is the create view command. So it's awesome that we can call it keyword. So the create view keyword now is the one we have to write to create a view. So when you write the create view keyword, it will be followed by the name you have to give a view. When you want to create a view, you must give the view a name. Just as we humans, you give birth to a child, you have to give the child a name. Okay, let's say you have a pet, or even more than one pet. You have to give such pet or pets a name or names for easy reference. So also is the view. Whenever we want to query the view or we want to refer to the view, we need a name that is assigned to the view. So now we create the view, followed by the view's name. And then after the view's name, we have the hash keyword. The hash keyword is very, very important in the sense that it serves as the bridge connection between the create view keyword and the name of the view and the select statement that would follow. Now, let me break it down. Now, we are creating a view in a particular name that will represent the select statement that will be followed. We are creating a view in a name that will contain the select statement that will follow. Let me paraphrase one more time. We are creating a view in a name as the select statement that will follow. I have to add that this view we are creating will return the same result set as the select statement that will follow. The view will return the same result set as the select statement that it keeps, that it contains. I hope this is self-explanatory. So that is what a view does. I am a view, I have a name, and I'm representing a select statement. I am a view, I have a name, and I will return the same result set as that select statement that you see below. So that is what it means, and that is how it will work. All this I'm going to demonstrate. Now, we have the syntax for creating a view. So also we have the syntax for creating a view to replace an existing view. Now, there's one keyword that we will have to add or replace keyword. So instead of just saying create view, maybe you want this view you want to create, this particular view you want to create, you realize that, oh, it seems we have created a view with a similar name in the past. Or maybe, you remember vividly or faintly that yes, there is a view in that name and we want to replace that view. So what you need to do is just to add the or replace view. So you have to create or replace view followed by the view's name as the select statement that would follow. That means you are creating a view to replace a view that exists in the database as the select statement that will follow. So that is how it works. Interesting, isn't it? Maybe, you can be confused and like, what are we saying? A view representing the select statement, blah, blah, blah. We can understand. We're going to find out more as we progress in this presentation. And finally, okay, we have our views. Okay, we keep saying, in the beginning, I said views do not have original data of their own, and they feed on the data from base tables that have been referenced in select statements. So we say it's a table and we say it's a view. What can actually, give us, make these clarifications clearer to us? And that is the show full table syntax. It really helps. If you just write this to query the database, it would give you, it will return a result set of two columns. The first column will give you a list of the tables in the database, and these tables will include the views. Well, the second column will now go a step further to tell you, hey, the first column has listed the views and the base tables as tables, but me, I will tell you which is a view and which is a base table. So those that are originally part of the database, those tables that are base tables that populate the database right from the start, that contain the data originally, are known as the database and they are distinguished, while those that are views are declared views. So that is what the syntax, that is what it shows. So let's go right into presentation now to see how everything works out. And then for the presentation, I'm going to be using my database. Yeah, this is my GitHub here. It's kind of blocking it. Okay, let's come back here. Very good. Okay, so this is my GitHub account. Here I have it. It is a project I actually wrote as part of the requirements for me passing the CFG, Introduction to Data and SQL course. So I'm going to be using that database for this presentation. So here and then, let me see, let me come back here. Now, for my presentation now, this database consists of 5 tables. It is originally populated with 5 base tables. And these 5 base tables include the categories, products, sales, suppliers, and salespersons tables. And these tables are related to one another in one way or the other. So these 5 tables now, we're going to be creating views based on these base tables. This is an example. Here, we are to list the ID, the name, and the weight of products with weights exceeding 0.5 kilogram. This is the select statement and the corresponding view. So to actually demonstrate this, I'll go straight to my SQL workbench and start. Now I'm using, the name of the database is the Express Grocery database. I have it already, my MySQL workbench. So all I need to do is just to activate it, the use statement. So, and I've done that already. So now, firstly, we're going to be creating views based on base tables. Now, the question says lists the ID, name, and then weight of products with weight exceeding 0.5 kg. Okay, now let's start. But before we start, I've always said this, and I will continue to say it. Firstly, how are these fields in the table? Definitely, we are going to the products table. How are the fields? How are they referenced? How are they named? We can see that directly from the schema. And then we have the product ID, product name, and then weight. So when we reference them according to the name that have been given in these fields, then we're not going to have any problem with our results set coming out fine. So for the ID, we have the select products ID, followed by the product name, and then weight. From products, the condition that weight is greater than 0.5. Let us try and check. Well, we have a result set. Now we have the ID, name, and weight of products whose weight is greater than 0.5. As we can see, the list weight we can see is 0.6. Yeah. So, since our code is working fine, we have this code. Maybe you write this. You're someone who works in the grocery store and you write this often, and then you need to rewrite this tomorrow, the day after, the day after the next. You don't have to discard it. You can just create a view. Remember the create view command. So I think we should give this the name kg plus. Remember the ASCII word I talked about as the select statement that would follow. So we just copy the select statement and then we come down here and then we have it. It works. It works successfully. You see the green tick. So one wonderful way of checking if it has really been successful again is by refreshing the schema. And then we go check the views. Wow. Yeah, and we see it here, half kg plus. Okay, let's check it directly from the schema. And then we have the same result set. Yeah, we have it. We have it. So alternatively, you can just use the select statement. Select all the data from the view half kg plus. And then we still have the same result set. Good. We have done it. So instead of having to rewrite select product ID, product name, weight from products where weight is greater than 0.5 every day, you just keep this select statement in the view. And then you query the view to return the same result set as the select statement. So that is how it works. So let's try another question. Okay. This time around, let's check. What do we have next? Now, next we have a list of ID, name, and phone number of all suppliers. Yes, we have a suppliers table. So let's go there. List of all of the ID, name, and phone number of all suppliers. Good. Now, we want to write a view to represent this, to return the same results as this. The first thing is writing a select statement. just as I did earlier. Now, the suppliers table, let's go there to check how these fields have been named, how they have been referenced. For the ID, we have supplier ID, we have supplier name, and we have phone number. So let's just write it accordingly, and we won't have any problem with our results set. Select supplier ID, supplier name, and then phone number. From suppliers. Good. So let's run our code. Let's execute it. And boom. Yeah, we have a total of 12 suppliers. So we have the names and their phone numbers. So let's check. Let's check. Let's try to do some fact checking. Yeah, we have just 12. And then we have our result set. Okay. The same old story. We want to keep writing this every day, and we want to save ourselves that stress. So we just create a view to keep it. These are mere supplier details. Supplier details. Then as we create it, give the name supplier details. It will represent, it will contain, and return the same result set as the select statement. So let's run it. It is successful. We see the green tick. Good. And let's refresh our schema to confirm again. Wow, this is a reconfirmation. We have our supplier details, and then we have the 12 suppliers, their ID, names, and phone numbers right on board. That's good. And alternatively, you can just select all the data from supplier details. Okay. Yeah, we have it, the 12 suppliers. And now it is also possible, to select data sets from individual fields, like three fields there have been referenced. We can just retrieve information from one or two fields. For example, we can just select the supplier name from the view. The view is supplier details. And then what do we have? Oh my God. It's a typo. Sorry about that. So let's rerun it. Good. You see, these are just names of the 12 suppliers. So we can query the view for all the data or for data sets from individual fields that have been referenced in the select statement. So let's create one more view based on base tables in the database. What is the third question again? This says the total number of products in each category. Very good. And we're going to name the view product in category, product in cats. So let's go do that. So the total number of products in each category. Fine. So now, as usual, write a select statement, category ID, followed by the number. So we're going to count. So we're going to use the count aggregate function. No. Okay. Followed by the count products ID, the alias as total products, or should I say number of products? I think that appeals to me. So number of products, very good, from products. It's from the products table. group by category ID. And then we also order by category ID. We want to make sure we order a result set in the ascending order by category ID. So let's try to run it. Yeah, and we have it. Now, this result set shows 5 categories with distinct number of products in each category. The first category has 10 products, the second, 9, the third, 8, the fourth, 11, and the fifth, 7. So let's try to do some fact checking. Let's check the categories table. Yeah, we have 5 category IDs. Yes. So we are just on point. Okay, maybe we need to do this every day. I want to save ourselves that stress of having to revise the code. What do? We just create the view. I think this time around we can call this prod and the products in each category as the select statement. And then we run it. Wow, it's successful. Good. We see the blue tick. Then let's refresh our schema. So how many views do we have here now? Yes, we have products in category. Okay, let's check what's in there right live from the schema. And then we have it live on direct, the category IDs and the number of products in each category. Good. Yeah, then we can just select all, from the view. And what do we have? Good. We have everything. So rather than having to select blah, blah, blah from blah, 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 group by, order by every day, you just write it once. Create a view that will keep it as an object in the database. And then by querying the view, with just one line of code, you can retrieve this result set of the select statement that is contained in the view. So we have successfully created 3 views based on base tables. I am excited. I know you as well. So let's move on. This time around, we are creating views based on the views that we have created. Wow, this is becoming more intense. This time around, we have 2 questions. Just 2 questions. Okay, we can do this, can't we? We really can. So we're creating views based on the views created. Good. Now, the first question says we should retrieve the category ID. Retrieve category ID. Okay, a number of products from categories with ID greater than 2. Okay. We just created the product in category. So it's going to be based on that because that really tells us, it gives us the result set of the 5 categories and the number of products. Now we're interested in the ID and number of the ID, the category ID and number of products for products in categories with ID greater than 2. So we can just write a select statement. Select category ID. And remember, let me take you back here. We alias the number of products in this category as num of prod. So we can just write the alias. number of products from the view where weight is greater than 2. Oh, sorry, category ID. Sorry. Where category ID is greater than 2. Okay, fine. Was just, kind of conflating it with the weight. Okay, now select category ID, number of products from products in category, where the category ID is greater than 2. And then we have the result set for categories 3, 4, and 5. Let's check our schema. We haven't created the view yet. Now it's time for us to create the view to contain it. So create view. So we can just call this product in category 2. Yes, because the first is product in category, but this time it's something related, but kind of with a limited result set. So yeah, unless, okay, it's successful. So now, because we have created the view, it definitely reflects product in category 2, and then we have categories 3, 4, and 5, and the number of products in each category. So all these views, when we have them, we don't need to rewrite the select statements. They already contain, they keep the select statements for us. They have it, and then when we just query the view, and then the view returns a result set as that select statement that it has kept. So it's been a wonderful session so far. Creating views based on base tables and creating views based on views created. So it is time for us to now experiment creating views to replace existing views. Creating views to replace existing views. So the first is going to replace, okay, let's check it out here to make it clearer. Yeah, we have one more here, but because of time, I want us to just move straight to creating views to replace existing views. Yeah, we have 2 questions here. So we're going to take the first. The first is replacing half kg plus. So half kg plus. So here we're going to retrieve ID, name, phone number of I'm writing the question for the second one. Okay, I'm just going to replacing the ID, name, and weight of products with weight greater than 0.5 and have not been sold. Okay, let me take you back to half kg plus so I can understand what we're about to do here, the difference between the first and the second one. It says we should list the ID, name, and weight of products with weights exceeding 0.5 kg. Good. Now here, you're retrieving the ID, name, and weight of products with weight greater than 0.5 and have not been sold. That is the addition. So we are going to create a create a view now to replace the half kg plus the previous one that we have created. Now, first is writing the select statement. Now we're going to select the ID, definitely the product ID. And then we have the product name and then the weight from products left join sales, because now sales is affected. Sales is also involved. Now I can choose to alias this, but I just choose to leave it that way. But if we want to learn the alias way, I'm going to write the alias version after this. But for now, let's just keep it simple so that it can be easy to understand. So let join sales on products. We're going to join both tables based on the field where they have a common value. Now let's go check the sales table. Sales table, there's a product ID, and luckily for us in product table, there is a product ID. So they have a common field there. So based on products, dot products ID equals sales dot products ID, where, remember, there are conditions, where weight is greater than 0.5, and I think we should just use sales amount, sales amount, sales underscore amount is no. That is where there is no sales. So let's try to check this out. Wow, it's not working. Why? Product ID from products, sales amount. Okay, let me alias here for clarity. From products P, let join sales S on P, because that would waste. Okay, on P, that's product ID, was S, the product ID, where the P weight is greater than 0.5 and S, the sales amount, is not. So let's check it now. Wow, it works. It can really work without the aliasing though, as long as they do not share the same, you know, okay, they do not share the same field name. But one thing is, both the products and the sales table, they share the product field. They share the field with the same name product field. That the product ID fields that can be responsible. So aliasing it really gives us the result set without stress. So it has always been preached, it's best practice when you write a join that you have to alias it. And that is what I always do. But sometimes I just look at when you have fields that are not in the same tables as are referenced, you kind of ignore the alias, but it's not. I don't have to go through that answer tonight. It's fine, we have an answer. So now look at the answer we have to go through. Okay, I don't have to alias it, then I have to alias it. All these, okay, you write the code just once and then it works. So instead of discarding it, we just have to create a view and then we can call it. Remember, we are replacing half kg plus. Comment. You have to tell me whatever is wrong with this. Okay, now let's see if this would really work. It didn't work. And guess what? Why? We are creating a view to replace an existing view. You see, it says table half kg plus already exists. So we forgot to what? Add our or replace keyword. So now it would work. Good. It's successful. We have a green tick, and then let ours come here. Okay. Let's check a schema. Yeah, we just replaced it anyway. So, but then the result set is different. Now we now have the result set for products, for ID, name and weight of products are greater than 0.5 kg in weight and have not been sold. Good. So now let's do the very last one. Yeah, that was the question I popped into rather than the first or the previous one. Now the last one says we should retrieve the ID and phone number of suppliers who supply products in the frozen foods category. This is very, very interesting. Okay, so let's check it out here. Yeah, the ID, name, and phone number of all suppliers who supply products in the frozen foods category. And this will replace the supplier details. Very good. So let's go there. So the first thing is write a select statement. I definitely know that this would involve subqueries. Now, three things are involved. First is getting to retrieve the data of, okay, how do we know the ID of products in the frozen foods category? First thing is we have to obtain the ID of the category where the category name is frozen foods. Now, first is we select category ID from the name of the table is categories where category name equals frozen foods. Yeah, that is the first thing. So let's go there. Good. We have one. And then if we try to check our facts from here. What do we have here? We have the same. The first category, frozen foods. As you can see, they correlate. Now, that is the first step. That's our first, that will be the innermost query. Now, the next thing is we are going to select the ID of suppliers who supply the products in the frozen foods category. If we go to the products table, we find out that the supplier ID is referenced there as a foreign key, so we have no problems. Doing this, all we need to query is the products table. So we select supplier ID from products where category ID, remember what we got the other time, right? Category ID equals 1. And then we have it. Now we have recurring values. So to correct that, we just write distinct supplier ID from products. And then as you can see, we have just 1, 2, 3, and 8, and then the recall. So we want non-recurring values, 1, 2, 3, and 8. Okay, fine. So we have the second. Now we now have a final, which is going to be the outermost query, which is retrieving the ID, select the ID of suppliers. Remember, we have supplier ID, supplier name, and then we have a supplier with the phone number, sorry. From suppliers where supplier ID in, yeah. So we need that. We need our outer query. Select, indent for clarity. Okay. Select distinct supplier from products where category ID in, remember, that one is the result set, is the result set for this. Select. Yeah, frozen foods. This is a long process. Imagine what, the stress we have to go through. First, trying to retrieve the category ID, where the category name is frozen foods. Then from there, we supply distinct supplier of products with, in that category, and then the details of the suppliers in that category. So now let's try to run a code. Wow, we have it. The name and the phone number of the suppliers. Coming. Okay, I see that. I included the supply ID, but I missed out the comma. Okay, good. Yeah, we have it. Yeah, we have it. Because we are required to get three data sets, the ID, the name, and the supplier and the phone number. So we now have the supplier ID, the supplier name, and the phone number. Having to rewrite this every day can be a lot of stress. So what we need to do now to keep it, remember, we are creating to replace. So create or replace supplier details as the code we have just written. Code we have just written, and then here we have boom. So let's try to create our something is not right. Something is not right. Why is it giving me an error? Frozen foods. Everything is okay. What's wrong? Supplier details. Oh, view. I didn't know I missed that. Oh God, that's interesting. Ah, okay. Create or replace view supplier details, and it works. Yeah, that's just like a bug issue. Okay, and then let's us. Hmm. I've refreshed the schema, and then we have our supplier details. It's a replacement anyway, but then with a different, it contains a new select statement that gives us the ID, name, and phone number of suppliers who supply foods in the frozen foods category. This has been intense, and using MySQL to create views has really, given us a lot of insights into how they work to make coding, like querying the database less stressful. Look at it, all of this now with just one line of code, just selecting all data from supplier details, and then your you have your result set, the same result set. You see? So rather than having to go through writing three queries, it's like three in one. The innermost, the outer, and the outermost. With just one line of code, you get the same result set. So these have demonstrated how the view can really help us, to keep our select statements, when we write them, and we need to use them often, we don't need to discard them. We don't need to throw them away. We don't need to delete them. We can keep them. And one way of keeping them is by creating a view where we will keep them, a view that will contain them, a view that will represent them, a view that will return the same result set as the select statement when it is queried. So that is the essence of all. And remember that I told you about the show full tables. Or we say that a view is a virtual table. We say it's a table, but at the same time, it is, can be distinguished from other tables in the sense that those that are originally part of the database, those that hold the data of the database, those that populate the database are the base tables. For example, and then let me just go back just to revisit. In the database I just used, there are 5 base tables because these are the tables that are originally part of the database. Good. So, but the views are now created based on the data sets that are referenced from these base tables or from views that already exist in the database in the select statement they contain. They are based on this data set from fields in the different base tables or views that already exist in the database that are referenced in the select statement that they contain. So now the show for tables will list these views as tables, but also clarify the table type, distinguishing between the base tables and then the views. So let's use the show full tables to see what I mean. Good. Now here we have, okay, let me just expand this. Very good. Now we have five base tables, remember? Categories, products, sales, salespersons, and suppliers. And then we have 4 views. Half kg plus, the one we replaced. Then products in category, then products in category 2, created based on this view. And then the supplier details we just replaced with another view that contains a new select, even more complex select statement. So so far we have looked into views. And again, it's one of my points that I highlighted in my PowerPoint presentation. And I have to say this now because I missed it out then, that access to a view is different from access to the base tables. As we said, the base tables contain the data in the database. So for you to get access to all the data in the database, I advise to go straight to the base tables. But if you want, information, data set from specific fields that have been highlighted in the view, definitely you'll be able to access this data that have been highlighted, that have been referenced in the select statement that the view holds right from the view. Now, to be more explicit, let me go back there. Now, let's look at this sales table, for instance. It's a base table and it has 6 fields. 1, 2, 3, 4, 5, 6. It has 6 fields. Now, in this 6 fields, remember the join we wrote, the left join, we have taken only the sales amount, just only the sales amount. And from the products table, it has like 10 fields, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have taken just the ID, the name, and the weight. Therefore, through the view, we can access the sales amount from the sales table only, as well as the product ID, product name, and weight only from the products table. 1 field from the sales table, 3 fields from the products table, making 4 fields. Meanwhile, each base table have more than this number of fields that we have referenced. We have just referenced it based on their relevance to the data we want to extract from the database. Now, look at the sales table. It has a whole of 6 fields. So you cannot access the sales ID, the sales date, the salesperson's ID, the product ID, and the quantity quantity from the view. It is not possible because they are not referenced in the view. But I can assure you, you can access the sales amount. That is the data that is referenced in the SQL statement that the view has contained. Also, the products table, you cannot access the brand, the unit, the price, as well as the date created, modified, category ID, supply ID, all of these from the products table because they are not referenced in the view. But I can assure you, these three, product ID, name, and weight that have been referenced in the view can surely be accessed through the view. Meanwhile, there are constraints that can be applied to checkmate access to data and in base tables through views. But that is a topic for another day. So far, we have defined the view. We have been able to look at the syntax for creating the view. And then we have demonstrated how to create the views. We see how simple they can make coding be. Complex queries like that, like the left join, like the sub queries, those are really complex. These are complex queries. Yeah, with just one line of code querying the view, you can just get the same result set. You don't have to keep rewriting those codes again, again, and again. And this really, as I said earlier, it promotes code reusability and it relieves us of stress and makes life easy while coding. So views, they are very easy to create. So, and then, as I said, the store select statements as objects in a database for future use. We can just, go there, just create a view to reuse the code often as we want. And views are first combination of data from more than one base table of views. Yeah. Like in the subquery, we actually, reference data from the suppliers, from the products, from the categories, everything combined together and everything is contained in the view. And then with just one line of code, you just retrieve the same result set that represents that SQL statement right from the view. That is the beauty of using the view. I hope that you have gained immeasurably from today's presentation. Let us know if you really find this useful. Feel free to drop a comment in the comment section. Feel free to give us a thumbs up by liking this video. And I really encourage you to subscribe to this channel for more interesting concepts, discussions about concepts regarding maybe MySQL or some other programming languages. Thank you so much for following me from the very beginning to the very end. We did it and we can do more again and again. Thank you and God bless.
Well, thank you very much, Bukola. That was great. Thank you for showing us how all about views and how to create views in MySQL. Thank you. That's all for today, everybody. Bye.
Yeah.